To understand instance methods, we need to recall or recap what we know already about classes. We know that they contain data as well as methods to manipulate that data, correct? We also know that every instance of a class possesses the same data and they possess the same methods of that class. So all in all, what we can get at is that every object that has an instance of a class is assumed to possess the same data and have access to the same methods, correct? Let's have a look at figure 10.13. This shows the class diagram for a student class. We've got student, we've got the data fields, which is grade point average, which is declared as a num. It's also declared as private. We have two methods that manipulate that field variable. The first method sets the grade point average, and the second method allows us to retrieve or have access to our field data variable here. So all in all, we have one private data field. If we have a look at 10.14 here, this shows the pseudocode for the student class. This class has become the model for a new data type called student. How will we use this class? We will use it in an application. So here we are creating our objects. And these are one sophomore, one junior, one senior. So this will be first year, second year, third year students at Varsity College, for instance. Here is the class we've created. It's a student is the class. So to create an object or an instance of our student class here, we have to go student one sophomore. Just as you would for using a string class, you will go string new string. It is string one. It is basically using the string class and creating an object of that string class, an instance of that string class. So when we say we are using instance methods, these are instance methods that we have to use an object dot method name in order for us to actually use those instance methods. So we could have many different examples on different instances or different objects that you create of this student class. Each will have its own grade point average field, and each object will have access to this set and this get method. Now let's discuss storage location in a computer memory with multiple student objects. We have three objects here. We have one sophomore, one junior, and one senior. So these three objects are of the student class. It makes sense that each object should have its own grade point average field. But it kind of doesn't make sense if each student to have its own copy of these get and set methods, right? So creating identical copies of a method for each instance would be inefficient. How are we going to know which grade point average is being set or retrieved? Well, this is where our instance methods come in. This is a method that works appropriately with different objects. The student demo class over here contains only one copy of the get and set methods, which can work correctly for any number of instances. So it's going to work correctly for one sophomore, it's going to work correctly for one junior, and it's going to work correctly for one senior. Hence, it operates correctly yet differently for each separate instances of the student. So if you create 100 students and assign grade point averages to each of them, you would need 100 storage locations in computer memory. Only one copy of each instance method is stored in memory. So the computer needs a way to determine whose grade point average is actually being set or retrieved. Now, there is a mechanism that handles this problem. How students' addresses are passed from an application, like our demo here, to the instance methods of the student class. Now remember, only one copy of each method in student class is stored in memory, and each instantiated object, like one sophomore, one junior, and one senior, can only be used to a single method copy. So our method call onesophomore.setStudentGradePointAverage 2.6 is made, and this is a true method call. It's invisible, and it's automatically constructed. And when we do this, it includes a method address of a onesophomore object. Okay, let me explain this with a bit more graphics. So here we have our student class, which is defined, and here we have our demo class that creates our instances of our student class, our objects, so one sophomore, one junior, and one senior. So what we are doing here is we've got our one sophomore address here. This address is known as the this reference. Remember when I said there's a mechanism that handles this problem of knowing which student address or how a student's address is passed from an application to an instance method of our student class? Well, it's this address here. It's automatically creating a variable called a student address that holds an address of an object and passes it to any instance methods whenever that method is called. That is our this reference. We got one sophomore address, one junior address, and one senior address. So looking now at the grade point average method in the student class, it's invisible, this a student address, and it's automatically created a parameter and it's added to our parameter list. So our public void set grade point average a student address here, num GPA, and here we store our GPA grade point average into the appropriate student address, one sophomore, one junior, and one senior. So the parameter accepts the address of the student because the instance method belongs to the student class. So example, if working with an employee class, your address would be employee objects address. It is very important that these shaded addresses are not written as code in any program. They are secretly sent and received behind the scenes. Let's delve in a little bit more of this reference. This is a keyword. Okay, it's a keyword and it refers to a particular object. It's an automatically created variable. It holds the address of the student object in this example. It passes it to an instance method whenever the method is called. It refers to this particular object using the method. It's implicitly passed as a parameter to each instance method. Implicitly meaning that you can't really see it. Okay, it's secretly there. Identifiers within the method always mean exactly the same thing. So any field name, this is followed by a dot, followed by the same field name. Now, an example of an occasion when you might actually use this reference explicitly, so on purpose, so not secretly, would be when you use this reference with data fields, but it's not really required. So what we're going to do is we're going to use it within our instance methods. The following two identifiers, grade point average, mean exactly the same thing. So any fields name defined in the class, we just use this dot grade point average or this dot field name. So in example here of our set grade point average here, our num GPA, we just go this dot grade point average, which is our field variable here, is equal to GPA. Now this proves quite helpful because it kind of gives you a field name identifier, but it also refers to the same memory location with the equals assignment operator. So this cannot be used with method local variables like GPA. So why do we need to know this if this is already there? Well, back to who you're working for. Some organizations actually use this for clarity. When would you use this more explicitly is when you have a GPA and GPA, and let's say that is also GPA. So when your field variable, your local parameter variable here is all the same. So what it actually does, this here is omitted. The local parameter here will just assign itself. So in other words, you will have a incorrect field variable value, and when you return the field variable value, it will be empty because it will just be assigning itself the GPA to the GPA using just that one. It will be assigning itself. So if this isn't here, you will be assigning itself using whatever you passed from your application program. It will not be storing the value into your GPA. This allows you to store whatever comes from the outside world, stores it into your local variable, giving it a more explicit reference, and therefore you will have a value in your GPA if you have the this in front of the same variable name as such. Therefore, anytime a local variable in a method has the same identifier as the field is hidden. You must use the this reference to distinguish the field, which is this one, from the local variable.